Folks, hello and welcome to week 6. 3 weeks to go until we close out the course. And I just want to say once again, thank you to all of you for all the great work. You have also been a very kind and professional group on all the discussion boards and all your submissions for grading. So again, I just want to thank you for, again, being such a great group and so diligent about all your work. As we head into week 6, as you know, we've spent a lot of time focusing on our course project, and as you've worked through your project draft during week 5, you've noticed a lot of discussion about data and how data helps us drives decision making, and that is obviously a key element not only of the course but our personal and professional lives. So we're going to keep going on this theme of data, and this week talk even a little bit more formally about about the branch of statistics. And anytime that I teach a course in statistics, the first thing I tell my students is the most important thing that they'll learn in the course, or what I want them to learn in the course, is being able to understand and being able to articulate what statistics is and what it isn't. And oftentimes you will hear statistics gets a bad rap because not everyone knows how to differentiate between what statistics is and what it isn't, and how they make claims that may not be justified statistically. So we're going to get just a little bit of that discussion this week with some very nice topics, and I hope that everybody again finds this in conjunction with what we've done over the last couple of weeks as we've gone from data and again now more formally into a discussion of statistics. And by the way, I mentioned your and we'll talk about this a little bit more in the video, but your week 5 project draft. I will be working through those, and I hope to have all my feedback to you by midweek, at least by Wednesday or Thursday, so that you can continue to drive those and get them in shape for your final submission during week 7. And so let's go up here to the learning objectives in the upper left-hand corner. Distinguish between populations and samples. And the two sources or the two groups of data that we typically, I shouldn't say data, two groups of individuals or subjects or things that we study in statistics breaks down into populations and samples. And a population would be, if I wanted to understand something about habits of males in the United States, the population there would be all the males that currently live in the United States. And obviously it would be very difficult for me to get information or get input from every male in the United States. So instead of studying a population, I would use information about a sample. Let's say I could get some information from, I don't know, maybe 200 men from different parts of the United States to help me understand something about the population that I am studying. So we certainly want to make a clear distinction between populations and samples. And as we talk about, or as we reinforce concepts, terminology, and notation, you will see as you go through some of the computations that measures that are associated with samples, the notation for those will be different than the notation that will be used for similar computations related to a population. So we certainly want to be mindful of this notation difference between the two. Interpret confidence intervals and for proportions and samples. There is a branch of statistics called inferential statistics. There are really two branches of statistics, descriptive and inferential statistics. We may have talked a little bit about descriptive statistics already, but when we talk or when we get beyond the discussion of mean, median, and mode and those sorts of basic calculations about samples, and we start to get into this discussion of confidence intervals for proportions and samples, we have now bridged the gap, or we have bridged the divide between descriptive and inferential statistics. And there's a much larger discussion of probability that goes with that. We're not going to take up much of that this week, but the connection that you will find when you get into a formal class in statistics between descriptive and inferential statistics is a fairly rigorous study of probability. Interpret study results using statistical significance. This goes back to that idea of making sure that we understand what statistics is and what statistics isn't. And when we talk about statistical significance, what are we saying? So that will be a nice topic for this week as well. And then finally, evaluate a claim to indicate if the claim is justifiable. And this is similar to this discussion of confidence intervals. When we talk about evaluating a claim, typically we're talking about hypothesis testing. And those confidence intervals and hypothesis testing are typically the first two techniques that we talk about in inferential statistics. So you're going to get a really, really nice overview of that material this week. Assignments, participation activity in Zybooks. Notice that I said challenge activity in Zybooks as we typically have. I have lined that out because according to Module 6, there is no challenge activity this week. So it'll just be a participation activity. And based on what I looked at in Zybooks, that is a very healthy amount of work and challenging work. So that will be a challenge in itself, but I'm certainly looking forward to good work from this group. Let's see. So the 6.2 this week is discussion, and one of the most famous discussions in all of statistics when we start looking at what's called bivariate data, or as you might recall it from algebra, when we look at a group of ordered pairs, and this idea of correlation and causation. So this will be, I won't tip my hand into what this discussion is all about, but it is a very, very nice discussion to have when we start talking about bivariate data. And again, for all intents and purposes right now, we could just think of that from the old algebra days as a set of ordered pairs. And then quiz from chapter 6, statistics in everyday life. I don't think there's a whole lot to talk about this week in terms of the course project other than to say, again, I will be looking through your drafts to see where everybody stands and try to give you some constructive feedback on how to, again, drive this to a really nice and substantial final product. Again, I just want to make sure everybody is aware of, templates, making sure we're using the right templates, making sure that we're going through the rubrics very carefully to make sure that you all understand how I'm going to grade that work. And of course, I don't want anybody disappointed about grades. So making sure that you're in touch with that rubric and, using the right template for each submission is obviously a big deal. And then to wrap this up, let's, as we always do, let's go take a look at what's in the homework for this week in Zybooks. So we are in, learning module number 6. Participation activity in Zybooks. And as I recall my look through Zybooks, the first thing that you get is this discussion of, or understanding the difference between a population and a sample. And we just talked about that, in the basics of the video. So very simply, a sample is a subset of a population, or a sample is a part of a population. And samples are typically used to study some factor of a population using this idea of inferential statistics that we have talked about. And that is how, that's really what this first sentence in the second paragraph is all about, is, being able to make an estimate or being able to have some understanding of how a population acts or behaves based on the variable that you are studying about that population. So this will be a good discussion for us this week. Again, making sure we distinguish between populations and samples. Sample sizes, a very common phrase that you may hear now, especially if you watch a lot of sports. Announcers will, throw out some statistics about a certain player or a team, and they will say, but this is from a small sample size, meaning they've looked at a player over maybe 1 or 2 games or a team over 3 or 4 games. And typically, we are interested in a little bit of little bit bigger sample size to make those sorts of claims. So we will be talking about sample sizes this week and what the appropriate size of a sample should be in order to make a statistically sound claim about a population. And let's see, margin of error. I think probably the best way to talk about margin of error before you get too deep into this is, when we start talking about politics and we start looking at polls and how one candidate is doing versus another, and a TV show or an article may show some statistics, and they will be very clear, if not they should have been, about the margin of error that is associated with their sampling results. And I will just say one more time, again, this goes back to that idea of what I talked about at the beginning of the video, and that is being able to tell somebody what statistics is and what it isn't. And obviously these errors that we talk about are accepted in statistics, but certainly want to make sure that they're applied correctly. And again, we talked about confidence intervals. Again, really kind of the first take or the first look at inferential statistics. So this will be a nice exercise, and it looks to be very visual, which is helpful. There will be obviously some computations here that you'll have to go through, but a very nice visual to go with it as well. And let's see, margin of error examples. Again, this is a very, very key point of this discussion. Again, to make sure that you are clearly grounded in the basics of statistics. And then finally, as we talked about, as sort of that last course objective for week 6, and that is being able to make claims about groups. And this is a very, again, it follows on the heels of confidence intervals. And sometimes you'll see this referred to as hypothesis testing. I don't know that terminology is used in here, but we certainly would recognize this later on in a course in statistics as some hypothesis testing. And then as an element of that, how do we make claims about when we compare two groups? And that is all about statistical significance and something called p-values that you will see down the road. And there is your discussion of p-values as well. So we've got a very robust week coming up. Certainly, trying to talk about multiple techniques in inferential statistics in the same week is a big task. And like I said, there's an element of probability here that we will not talk about at length this week. Some of this becomes very visual, and that's also very nice, and it's a good way to start. But this will set you up very well, number one, to drive home that project, and then when you have to take a course in statistics, if you can recall this information, you'll be in great shape to get through that course. So again, I look forward to looking at the rest of your project drafts, and I will aim to have all my feedback to you by, say, Wednesday or Thursday of this week. Take care, have a great week, and please let me know if there's anything I can do for you.